Okay, so let's start 6.3. Oh, transitions. Can you solve this? 2 to what power will equal 6? 2 to what power will equal 6? Now you know 2 times 2, or 2 to the second, will be 4. What's 2 to the third? 2 times 2 times 2. 8. So I don't have a nice whole number for x, do I? So what? So you're guessing 1.5? 2.5? What do you get when you plug in 2.5? 5.65, so we could round that to 6, but I want exactly 6. So you're basically guessing and checking, right?
I got 2.58 gave me 5.9. 2 to the 2.6 gives you 6.06.
Okay, but so you're seeing though, you're rounding. You're having to round your answer, right? To get 6. Okay, but there is a way to actually solve for that exponent to get exactly 6. And that's what we do today. So 6 lovely transitions here. All right, 6.3 logarithms. So on your calculators, you should see a button. You actually should see 2. Log, L-O-G, and natural log, which is L-N. We'll cover natural log later. So we're going to start with that log button first. Okay, so don't mess with the calculator now because you don't know exactly how to do it. We all titled our notes? Okay. All right, so here is the definition of your logarithm. Okay, we are in base A to start. So it is just a function that's used to solve for exponents. Okay, no more guessing and checking. I want exact answers from now on. So here is your equation, basically. Do you remember what IFF stands for? If and only if. Which means it's true forwards and backwards.
The confusing thing, though, is knowing that the log key on the calculator defaults to base 10, how do you input a custom base?
I will show you. You will learn that. I don't remember if it's today or tomorrow, but we do. We do look at when it's not in base 10.
What does IFF?
If and only if. So you're going to work forwards and backwards with this. So you're going to have the equation y is equal to log, and how you read this. I don't know if the transition's up there. Okay, it is. Of course it is. All right. So you read this as log base A of x. So your base is your subscript, your little a. Okay? So you have to make sure that when you write this out, you don't have log of a times x. That a has to be a subscript. Okay, so you read that as y is equal to the log base a of x. And that's true if and only if we take a, your base, to the y, then that's equal to x. Okay? We'll work with these and make sense of them. Do we all have that written down? And do you have how to read it? I would write that down too. Log base a of x. That's how you say it. Got it? Okay. All right. So again, the definition tells you, and you don't have to necessarily write this down, but the definition tells you that those two equations are the same exact thing. But if you look at a to the y is equal to x, do I right now know how to technically solve for y, that exponent? The answer to that is no. So by rewriting it in the log form. So I'm basically going backwards. I'm going from the a to the y, and I'm going to rewrite it in the log function. And now, do you see that you no longer have an exponent in that function? Log base a of x is equal to y. So now this is allowing me, when I rewrite it into the log form from exponential form, do you understand that a to the y is exponential form? Because there's an exponent. When I write that into log form, now I can solve for an exponent, and I don't have to guess and check anymore. That's how you're going to do this. That's how you're going to solve for an exponent. So when you rewrite forms, you're going to look at this. So you see, first off, how do I read this? Evaluate, what is that? Log base 3 of 9 is equal to x. Okay, so you have to ask yourself a question. I'm going to show you a little method on how to remember this, which is a little bit easier. But if you look at the form, what is your base in this example? What's your base? What's your a? 3. What am I going to raise it to? Look at the general forms. You're going to raise it to x. Because isn't a raised to the y? What's your y in this case? It's x. Okay? So now you're going to ask yourself, 3 to the what power is 9? That's what you're going to ask yourself with these. 3 to what power is 9? And what's your answer, guys? 2. Yeah. 3 squared is simply 9. That's how you solve these. Oops. That's how you're going to solve these. You're going to rewrite your log form in exponential form, or your exponential form in log form, depending on what's easier at the time. And then it's just a simple calculator problem or mental math like this one. Okay? So make sure you do get everything written down today, because this is brand new stuff. Very, very important to write it down. So do you guys kind of see the pattern of how we thought 3 to what power is 9? 3 to the x is equal to 9 is basically what you're going to do. So you're going to basically make a circle. And I'll show you in just a minute. Okay. So here's your log form we're going to give you first. Read that again to me. Don't say of twice. Log base 2 of 16 is equal to 4. So I always use the circle method. Okay, just to remember what I start with, what my exponent is, and what my answer is. And I always have to cross the equal sign with my circle. So I'm going to take 2 to the power of 4 is equal to 16. That's how I will rewrite this. So your base gets raised to your answer, and that's equal to that last number that you have. So it's 2 to the 4th is equal to 16. So do you see how that circle is going to point to what, or how you rewrite the exponential form? So you always start at your base no matter what form you're in. So here's my question. If I'm in the exponential form, what is my base? The 2, right? Because technically you have a times b to the x, right? From back on Monday. 2 is that b value. So in this case, what's your a value? 1. Okay? So no matter what form you're in, always start your circle at your base and go across the equal sign with that first curve of the circle. Okay? So, next one. Log base 10 of 10 is equal to 1. So in your head, what are you thinking when you see log base 10 of 1? Sorry, log base 10 of 10 is equal to 1. Yep. 10 to the first is equal to 10. And you see that by starting at the base, going across the equal sign for the power, and then finishing with what's on the right side of the equal sign.
What are you really solving for then? Because like
You are technically solving for the exponent. They've given you the exponent here though, with these numbers out here. Technically that's what we're going to be solving for, is that number on the right hand side. We're just getting you used to seeing this and logically making sense of what that number is. That number that it's set equal to, that's your exponent. And that's usually what you're going to solve for. Okay, so now let's go backwards. I should write this one up here. So 10 to the first is equal to 10. So now let's go backwards. Let's go exponential form to logarithmic form. So in that exponential form, what is your base? 3. Okay, so do you understand that when you're going to logarithmic form, you have to start with a log? Because if I'm in logarithmic form, don't I have to have the log physically there? And then in exponential form, I physically have to have an exponent? Okay, so I'm going to start with the log here. And you said my base was what? 3. So log base 3. Where does my circle go now? To the first. So I read it as log base 3 of 1 equals 0. And this side, the exponential form, does that make sense why 3 to the 0 is 1? Okay. So then when you read the log form, you're thinking 3 to what power is going to give me 1? Okay, so you're always constantly thinking about the variable being the exponent, no matter what form you're in. Okay? This is making a little bit of sense. Okay, are you at least seeing the pattern on how you convert form to form? Okay. Log base 10 of 0.1 is equal to -1. Well, what is 0.1? 1/10. So we could even write this as log base 10 of 1/10 is equal to -1. And some of us might see that a little bit better. So where do I start the circle at? Your base, right? Your 10. Where does it go? Across the equal sign to the negative first. So I say that then as 10 to the negative first, correct? Is equal to what? 1/10. And I hope that makes sense. So 10 to the negative first is equal to 1/10 because that negative exponent flips your number. You take the reciprocal. There is one more. So are we okay on that one? Okay. Last one here. Now there's a decimal. So here is what that warm-up was. 2 to what power is equal to 6? How many got close to that? 2.585. Plugging that in. Yep. Okay, so some of us guessed that correctly. Now here's how you would actually figure that out. Because you would rewrite this as what? See if you can say it. Good. Log base 2 of 6 is equal to that 2.585. Good. And again, it's written as log base 2 of 6 is equal to 2.585. And this kind of goes back to what Mason asked. We're going to talk about what your calculator will do. So you can't just type this into the calculator and figure it out right now. You're going to have to do what's called a change of base if it's not in base 10. So we still are a little bit out from learning exactly how we got the 2.585, but we will figure that out in just a little bit. So the circle, for the most part, doesn't make sense on converting these forms. Okay. And again, bottom line, what is a logarithmic function for? To find an exponent. Okay, very good. Okay, now let's evaluate without a calculator because I haven't had to use a calculator yet. So here's what I'm going to give you. Log base 3 of 81 is equal to. And what are you thinking? Well, okay, hold on. You're just giving me a number. Now, how the heck did you get that number? Because you're thinking 3 to what power gives me 81. So I could put well, let's see what the transition is. Okay, so I could put a variable there. Okay, apparently not. Put a variable there and say 3 to what power is going to equal 81. And you said your answer was 4. Okay. What about log base 5 of 125? 5 to what power is equal to 125? And you're saying x is equal to 3. Because 5 times 5 times 5 gives me 125. So make sure you're writing these examples down too. The more examples you see, the more this is going to make sense and the easier this will be. So please make sure you're writing it down. When it comes to the quiz and the test, I do need to see this work too. I do need to see you going from the log function to the exponential function. That's your work, okay? Because I know we can do this mental math easily, but I need to see what that mental math was in order to get that answer. Does that make sense? Okay.
For like the ones without like a calculator, they're not gonna be like super big exponents, right?
No, they won't be rough. No, they won't be big. Log base 4 of 256. So again, what are you thinking in your head? Good. 4 to the what power? 4 to the x is equal to 256. And what's that? So 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256. So x is equal to 4.
Wait, couldn't you like still just use your calculator for that part, Jen?
That part you can, and that's why I'm saying I want to see this work so I know what you're typing into the calculator.
Okay, so it sounds like a calculator is still useful and you just have to like show it.
Yes, exactly. Because right now you don't know change of base in order to actually get that answer using the log form. No. Ooh, what about this? Log base 2 of 1 over 32. So think about this for a second before you give me an answer because you're using your calculator and not doing what I'm asking you to. You're going to think 2 to what power is equal to 1 over 32? It's going to be a negative number. Why? Why is it a negative number? How'd you know that? Well, because you started with the base of 2, right? And now your answer is a fraction. 2 is a whole number. 1/32 is a fraction. So 2 to what power is 1/32? Well, basically, 2 to what power is going to get you 32? 5. Now make it negative. Does that make sense?
I understand this. I'm so happy.
Good. Good. I'm glad we're understanding it so far. Okay. So any more questions on these types of problems? Okay?
Stop right there.
No, we can't stop right there. Not quite. Okay. So now you try these. Try these four real quick.
You're still rounding.
So compare with your group what you think these four answers are. Do we need a little more time, especially on that last one? Okay.
Maybe just that word lines on the graph or it's error. Because negative zero and zero are the same thing. Zero is negative power. Therefore, I'm trying to figure out myself and those changes.
All right, do we think we have them? All right, so 4 to what power is 16? 2? Oh, apparently we don't have transitions there. All right, so you're thinking 4 to what power is equal to 16? So x is equal to 2, correct? All right, what are you thinking on the second one? No, what are you thinking? Yep. 5 to the what power is equal to 1, so x is equal to 0. Okay, and then the next one you're thinking? X equals, okay, because that's so small. X equals 1/2? Yeah. Because what are you really doing to 4 to get 2? You're square rooting it, right? You square root 4 to get 2. Well, just remember what we do when we change a root to the exponent. So if I cube root something, it'd be 1/3. Okay? What if I squared the number and then took the cube root? What's my exponent? See if you remember these rules. 2/3. Because the root is in the denominator, and then whatever you do power-wise is on top. So if you have a cube root and you square it, it's 2/3. Okay? Now, 3 to what power is -1?
I feel like you have to put it in some kind of it's undefined.
Undefined? Error? Why? Well, yeah, you're thinking the only way to get a number, to get your base down to 1 is raising it to the 0 power, right?
Does this have something to do with complex numbers?
Are we talking imaginary? I'm going to leave it at this right now. We're not going to dive into that just yet. But I'm glad that you thought, Can I raise it to the 0 and get 1? And that answer is yes, but it's a negative 1, and you know 0 is not negative nor positive, correct? So right now we're going to call it an error. Can't do it. Good. Okay, natural logarithms. Natural logarithms. This is your second button on the calculator that you'll need, the LN. Now, the thing that changes here is your base. So far, in order to use the calculator, which, again, we really haven't just yet, but if you want to use the log button in your calculator, your base has to be 10. So far, we haven't really used a base 10 in our examples. So that's why we haven't plugged anything in. But the natural log has a base of E. LN. Yeah, so it's natural log, but they put LN instead. That's just what they do. So what you have to think of is when I rewrite this, with that E, you're never going to see log base E of X. You're always going to see natural log of X. So what you want to think about is technically there is an E right there. So when you do the circle method to rewrite, to take your base and raise it to your exponent, you have to pay attention that that E is there, but it's never written. Because you'll never have the natural log form written as log base E. Okay? So we got that equation right there? Okay. Just said that. Okay. Here are some common logs. This is what I'm talking about when we say log base 10. Because it's so common and because it's used so much, you won't actually ever see it written as log base 10 of X. It's just going to be log of X. But you'll still say it as log base 10 of X. Okay, so if I ever give you a logarithmic function where you don't physically see a base written, you know it's base 10. So you can use your calculator. Okay, so when you read the one on the right here, you're still going to say log base 10 of X. But then it's just not written. That's what I just said. Okay. And we have found them on our calculators. So I know this is not typically what we have as a calculator, but you found your, I think they're circled for me, your log and your natural log. They should be right next to each other. Or some of you might have to go under mode. Something like that. But we all found them? Okay. That's it. That's it for today. So we will graph these tomorrow. So right now you're just working on rewriting them and kind of logically evaluating them. Tomorrow, though, we're going to graph.